Recently, I really wanted to find a good tutorial on how to make this type of stuff. Or this. Or even this. But the problem was that those kinds of 2D experiences were made with JavaScript classes approach. But back then I needed a tutorial made specifically for React, so I decided to teach myself on how to operate with a library called the React PIXI. Also, I came up with a process to prepare the basic assets for the scene, so that you could make your 2D experience really fast. In this video, I am going to show you everything you need to know to create this type of 2D pixelated experience, whether be it for the game you want to start creating or a portfolio website. So first, let's get straight to the point by opening the terminal. npm create vite latest, and we're installing in the same directory. So here just choose React. Then what we have to do is just npm install. Let's speed up a bit. Then npm run dev and we're good to go. Now what we're doing is just cleaning up the project. We don't need that in our initial setup, so we can just remove everything. Just like that. We don't need this count here. Don't need logos. No CSS. And we have to put some kind of basic CSS for the root. That's what we're doing now. So let's just put to the body padding of 0, margin 0 as well. What this is doing is basically gives us all the available space that we're gonna be using. But yeah, maybe let's try root, because anyway, the whole area is the root. And let's put height to 100%. And I think we're mostly set up here. So first things first is the whole structure that we're going to be using. Actually, I do like arrow functions, but let's take a look what we have. And yeah, we have rendered just hello for now, but that's going to be a good starting point. Now let's just focus on the structure of our project. Let's create a components folder, followed by the experience folder, and also the levels folder, of course. Now let's create the constants folder that's going to be having the constants for the project, the helpers, and the types. Basically, the structure that we're using on real projects. Yeah, nothing's changed for now. Okay, so here let's create our arrow function. It's going to be basically the same. And here we're gonna have our first component, which is called experience. We export our function. So let's just go ahead and create our experience component in a folder that already exists. All right. Here we can use RSC shortcut. Yeah, here let's just delete the unneeded code. And what I think is we don't need the default export, so let's just change that as well. Now let's go back to the app component and let's import our experience file. All right. So now look, just because this is a PIXI React project, we need to install the dependencies. Let's just go ahead and npm install PIXI React. But this dependency actually needs the other one, which is called pixi.js, which is a main library. All right, so let's speed up a bit. Okay, it is installed, but make sure to install the actual versions that I use. So let's start with the stage, because the stage is the main wrapper, let's say, for the whole PIXI experience. We just import stage, and what we need to do is to actually use this stage, but it has some parameters. And this is basically width and height, because the stage needs that to create some kind of canvas under the hood so that it can render the whole experience. For now, let's just pass some basic values like 500 and 500. Let's take a look. All right, we have rendered some black square, but it's just a canvas which is not resizable. That's why I think to make it resizable would be a good idea. So let's just go ahead and do this. So first, let's just go ahead and create a function which should be called calculate canvas size. And what we're doing is we're using the window object that inner width and put it to the width. And the same goes for the height, then we just return those two. There we go. But now let's just think about using this function. And first thing that came up to my mind is to actually store somewhere the size of the stage. So let's call it canvas size. And I think the good idea would be to put the default value as the function calculation right after that. And the good practice would be to export this function and put it in helpers folder. Let's create a file called, let's say, common.ts. And we're just putting our function there. All right. Let's just import it here. Okay. Now let's create a function to actually update canvas size, and let's put it in a callback. That would basically prevent the recreation of that function between re-renders, and the re-render will actually happen when we resize. All right, call this function to the set canvas size. Then let's just go ahead and create the event listeners, and we're going to be using useEffect to add the event listener. Okay, resize event, and we're using the function to recalculate the canvas size or update it. But we also want to clean up the component, and we're doing this in the return. We just remove the event listener. Now it's time to use the canvas size. And let's put the width and height parameter from this object, and we're good to go. Now let's just take a look at the documentation to check out what we just did. So let's talk about the container. The container is something that contains the sprites, and those containers are within the stage. So we can think of this as some kind of character of your game being a container that can have weapons, clothes, and so on. So what we're doing here is we're creating the main container props that we're going to be using, and we have the canvas size. Alright, let's put the width and height, and now we're just using those props in the main container. So let's just pass it, and we have this canvas size, children as a parameter, and we have props with children, which is coming from the React library itself, and we just put our props type there. The whole concept of the container in our case would be just, like the container is a wrapper that actually contains everything that we have on the scene, and whatever we put inside of this container as a children prop would be resizable, and it will be within the boundaries of the container itself. Now what we need is the sprite, and this sprite will be displaying the background. And you guess what? The sprite would be resizable by receiving the width and height properties that we already created. And the next property would be the texture, because the sprite should display the texture. So I just picked a random one, the starry texture. You can actually add whatever you want, doesn't really matter. Then to add this texture, we need to create some kind of variable to hold one. So let's call it background texture equals texture, which is coming from pixi.js, and from background, let's call it background asset. So as you can see, I already have in the assets folder the image that we're going to be using. So I'm just importing this. Yeah, a bit weird import path, but we don't have time for setting up the aliases. So let's just wrap this texture with a use memo. And we're doing so mostly because we don't have to face any performance issues in the future. So we're saving the texture between the re-renders in the memory. There we go. Now going back to the experience component, what we're doing is just importing the main container. And of course, don't forget about the props that we need to pass, the canvas size. We already prepared this one. There we go, and that's it for the main container. So let's take a look at this one. Okay, we have this background, and what we can do, we can try to resize it. All right. So as you can see, it can be easily resized. Now it's time to think about our level. So what you need to do is just go ahead and visit this itch.io and choose whatever you want. There are a lot of free options out there. Then you just go ahead and click on whatever tile map you want, and you click download now. I encourage you to support the authors as well, of course, or you can just download it. But in this video, the tile map is from there, from opengameart.org. But that's not it, because now let's talk about the tile editors. And what I personally use is Sprite Fusion. It has pretty cool interface. And the reason you want to use the tile editor is because you don't want to just download the tile map from the internet, I believe. You rather create your own tile map, meaning the level, and you're doing so by just simply putting the image right there. Then you just select the area you want to paint with, and then you propagate it to the field which is going to be your tile map after you export it. Then let's talk about the export. So I created some kind of tile map. You just go ahead and click export. Very simple. And you choose PNG. All right, after about half an hour, I have my own tile map, which I can use. And we're going to be using it in the level component. So let's create the level component. All right, just clean up a bit. Export, okay, without the default export. And what is the level? Basically, that's a sprite with our tile map. All right, and it has parameters. The image would be our tile map, or rather our tile map texture, width and height. But also it would have an X property and Y property, because the library should know where we put this image. Now we just import the asset, of course. Let's call it level asset from assets and tile map. There we go. Now we just use this level asset. Okay, but what should be here? We have width and height, but because the level tend to change, let's store those values somewhere. So let's create the game world, and this file will be having all of the constants that we have. So the first one would be the tile size, and you know that just by looking at the resolution of the tile map. The next one would be the columns and then rows. And as we take a look at this one, we have 24 by 15 tiles. But personally, I really like to add some boundary level. So one extra tile on each side, meaning that 26 by 17 that would be. Alright, now we dynamically specify the game width, which is tile size times columns minus tile size times 2. Later you will see why we're doing so. There we go. Rows, tile size multiplied by 2. Alright. Now we're just specifying those. Of course, auto imports. And here you want to create the offset variables. But in this course, I would specifically demonstrate the offset and why it's really helpful. In our case, it would be tile size divided by 2. And it's because, as you can see on top, we have half of the tile, which is not walkable. So we specify the offset there. And now it's time to use our component. So we're gonna do exactly the same thing. Add in the level and importing that. There we go. So let's check out the result. Here we go. So that's what we have. Now it's time to add our collision map already, and I'm just creating the collision map file and putting my collision map. Actually, it took some time to create this one, and you just fill it up manually, for example. Or, of course, you can create this dynamically as well, but I did it manually. Concept is super easy. 0 means you can walk there, 1 means you cannot, and that's it. Anyway, we will get back to our collision map in a while, but for now let's just bring some life to our Pixi scene by creating a main character. Let's call it Hero. The rest you just do the same. Just create a component, scaffolding the basic component, exporting the component function. There we go. Just clean up a bit. Okay. And now it's time to create the sprites for our character, or rather sprite sheet. So you just go to this liberated pixelcup.github.io, sprite sheet creator. The link will be actually given to you in the description below. So this is pretty cool sprite sheet generator where you can generate some of amazing sprite sheets for a main character or NPCs. It's quite customizable, I'd say. It's open source as well. You can download the sprite sheet with just one click. You have preview. Yeah, and just one click to download as PNG. And that's what I have. And as you can notice here, from row 9, we have character movement based on a direction. So let's use that. But before, let's just import our hero component. For now, let's put it right next to the level component. Just like that. Okay. So now we're specifying the texture, and we want to pass down texture to the hero component just because hero component would be re-rendering a lot of times, about 60 frames per second, and each time we don't want to load the texture for the hero component. So that's why we're just loading the texture one time and passing it down to the hero component. Also adding the sprite to hold that texture. And of course, to receive that, we need to create properties by specifying the interface. So would be the texture. And let's also create onMove function. We're gonna need that later. This function will receive grid-based coordinates after main character's movement is done. And it's mostly because we don't want to store the character's information in the character itself. Okay, the texture on move. And now, okay, now we have to pass down those properties to the hero component. And with this process, you're already quite familiar. We just pass down the texture, just like the background texture. It's exactly the same, but the assets should be different. And that's why I'm gonna change it right there. Hero asset, All right, I already uploaded this. Okay. Okay, now let's just create the variable that will hold the coordinates, the position. Let's create a state here. All right, hero position, set hero position. Use state, and let's put X and Y coordinates. Okay, here what we're doing is we're creating the function to update hero position. This function will be called when the movement is complete. And of course, it's going to receive the coordinates. And pay attention to that thingy. Math.floor is going to be used because we want to snap the hero to our grid-based system. And let's wrap it up with our callback after this, okay? Because we don't want re-renders, recreations of the function each time, because the main container would be also re-rendered quite a lot. So, all right. Now what we want to do is to go back to the hero component and use those properties to set up the hero. Okay. So let's create our position. Okay, and we're using useRef just because we want to track the change of the value, meaning track the change of the position, but we don't want to necessarily re-render anything. And you'll see why. For now, let's just create our default position for both X and Y. It should be the tile size, let's say multiplied by 10. So meaning X10, which basically means 10 tiles to the right. The same goes for Y-axis. Let's just put 15 here. And we're going back to the hero component and importing those default values. There we go. And now take a look at this one. We're using useEffect here. And what we want to do is we want to use this onMove function. And we call it inside the useEffect, basically informing the parent component about the re-render of the hero component. And we're doing it just once, basically. The next step here would be to use this texture on sprite. So let's just pass this texture here. And let's pass the coordinates. So we have this position, and those coordinates are from the ref. So we have .current.x, .current.y. All right. And also let's put a scale there. It's straightforward. You don't have to guess what that means. You just have to configure yourself based on the size of your character. And also we have anchor. Anchor basically means the offset. All right, getting back to the main container. Okay, what I already see is that we're not using the right texture. Okay, let's change it to the hero asset. And let's check out what we have. So if you have something like that, that means you absolutely nailed it. What we do is we're showing the whole sprite sheet. Maybe you'd ask how to create animations from this sprite sheet, but first, the animation should be based on some input, and in our case, it would be the keyboard input. So this keyboard input should control the whole animation flow. So now let's create the basis of the control system for our game-like experience. So first, let's create the position interface, because I've already observed that we use those X and Y quite a lot. Of course, it's a really good idea to create a type for that, or rather interface. And here we're creating the direction type. This direction type would be used to indicate the direction that is coming from the keyboard input. All right. Now we're going to create, I think, our utility hook. So let's just call it use hero controls. All right. And the same goes here. Okay. So now let's create a map functionality. Direction keys. Okay. So it would be a record with the type string and the type direction that we just created. And it would be mapping the input from the keyboard to the direction, and that's it. And we're doing all right, WASD, and also the same goes for the arrow keys. Okay. Yeah, but let's put it somewhere else. For that, we already created the structure. Let's put it in maybe here in types. Or, to be honest, I don't know. Maybe it's better to put it in the game world because it's constants or whatever. Let's put it here for now. So for the controls, one of the best practice is to keep track of the held direction, and we're gonna store the directions in an array. All right, this array of direction. Okay. And we're gonna handle the keys by putting the value to this array of direction. That way we can handle a few keys simultaneously, and that's why it's a good practice. Because when we hold two keys at the same time, the priority direction will always be the last. But when we release any key, the direction will be the one that we're still holding. Alright, I created some kind of template here. And now let's create the getControlsDirection function. Of course, wrapped up with the useCallback. Basically, this function will be always returning the current direction. And here, it's time to create this handler. We have the direction keys. We also need the event, the keyboard event. And the flag, whether is the key down or not. Okay. And here we just pass the key code from the event. And then if the direction isn't there, we just return. If it's key down, we just return the value, whether it is there in the previous values. Not sure if I actually understood what I just said, but basically it's meaning when we hold two buttons and we release one, the previous one would be a priority, and that's it. Otherwise, we just filter based on the direction, but we already have the direction word here, so let's just maybe name it differently, as a dir, or yeah, something like that. Dir direction. And if it's not equal to direction, we just we return it. Okay. All right, now it's time to pass our listeners, basically to create the listeners and attach them. Okay, let's create a handle key, listener, handle key down and a handle key up. Basically it's the same, but yeah. Is key down property is either true or false. Then we just add the event listener to the window, whether it's key down or key up. So based on this, we just either pass a property as a true or not. As you can see, yeah, it's basically the same. So let's just copy that. Okay, and as you can see, something is not right. So let's take a look what's happening. All right, the keyboard event. I believe it's just a mismatch of the type of the keyboard event. But for now, let's just remove the event listeners, basically making this cleanup function here. Okay. And now we're gonna fix that in a moment. Okay. So as you can see, we have keyboard event, but yeah, exactly. It's because of the import of the keyboard event. We should not import that because it's coming from React. We need to use the default one. There we go. So we do not have any errors anymore. Let's just return the actual value from here. So we'll return the held direction array, the first value of that array, or null if it's not there, because sometimes we don't have a value, right? When you do not press any keyboard buttons, anything like that, you don't have a value, and that's okay. Now going back to the hero component, let's just test what we just implemented. So we import the use hero controls and we get the function get controls direction from there. Now let's create some kind of variable to hold this. Yeah, something like that. And let's take a look at what this test returns. As you can see, we have our console here. So now I'm pressing the values, the actual values. But something is not right because I'm pressing down right now. Let's take a look. Oh yeah, exactly. That was just a typo here. So let's check. Yeah, I think that should be fine. Let's go back and check. Okay, now I'm pressing yes. That's exactly what I need. So that's the actual value. All right. And now we are able to start setting up the movement. So let's create a function calculate new target. Let's take a look here. Okay, and here we have the use tick. Well, basically that means the function which is ran on each frame re-render. Now we have this check can move function. Well, before moving, we need to know whether we can move there based on our collision map. Okay. So yeah, here, based on our position, we have the direction, and we just need to calculate the new target using this information. And we're doing this by actually using a very simple formula. So here we need to use, of course, we're using the tile-based geometry. So here we just do the following. X and Y. This is going to be the basis of our coordinate system, but we need to increment by using the direction, and the increment itself would be the tile. So based on direction, whether it's left, we decrease the tile size, otherwise we add up, or rather checking if it's right, and then edit. Otherwise, doing nothing. Okay, the same goes for y-axis, just changing the directions up and down. All right, now we're ready to go with the check and move function. And of course, this function is based on the collision map. Essentially, what we're trying to do here is the next move that we're going to make, we need to check if it's 1 or 0 based on the collision map. So we have an input here, the target, and here we want to define the row, which is going to be based on the target and y divided by the tile size. Why is the row based on a y-axis? Well, it's because it's the change. And maybe you're familiar with matrices, but for example, in this case, when the y-coordinate changes, what we're actually changing is the row. The same goes for the column, and the index would be the column number multiplied by row plus column as an offset. That's why we're storing the values in one-dimensional array. And here we check if index is less than 0 or index more or equals to, and then grabbing the collision map and length. All right. And now we want to return false, meaning we cannot move there. Otherwise, if it's not 1, we also return. Basically, returning the true whether it's a 0. The next function would be handle movement. And this is going to have the parameters, the current position, the target position, the move speed, and a delta. A delta which is going to be used in optimization techniques is going to be a crucial one. Now let's define a step, which is move speed multiplied by tile size times delta, and the distance, look carefully here, target position x minus current position x, target position y minus current position y. So we're using the math hypotenuse to calculate the distance. Just basic math here, nothing special. Now, when the distance is less than or equal to step, we consider it done. So we do the completed true and return the position. In other case, we basically continue the movement, and the completed should be false. So our current goal is to create a function to actually move. So let's create continue movement. All right, and let's create move towards. Okay. So those two we're going to be using. Now look at this. Basically, we want to have the same inputs because we're gonna use those current position and target position a lot in those calculations, but let's change a bit. Let's put a step here. Okay, it will return the coordinates as the position. So basic setup for this behavior would be like we have the continue movement function, which is going to be using the move towards function, and here we define the basic movement. Let's just return the current target and a max step, which is going to be a number, and a number, because that way it's much easier to calculate. So some basic math formulas. So what we're doing here is technically we're taking the path of least resistance, so we're just going the minimum path. So no matter what is used, whether X or Y, we're just applying this change to the current position while also taking into account the max step. So here, here it's ready. Now let's just use the move towards function, current position, target position, and the step. In a while, you're gonna understand why we need this step. Okay, let's pass the value here. The step, right. So the step is essentially a multiplier which can be used to optimize the animation. So here we have delta. The delta is basically the difference, the time frame between the frames. And by knowing that information, we can optimize our animation so that it runs smoothly on any device. This technique is really common in game development, and I think something similar can be found anywhere. Now we're just checking if the direction is there. And here we need to set the next target if it is there. Otherwise, we should handle movement, and at the end we need to handle the completion of the movement. So those are the things that we need to do in our use tick. So let's create the functions. Alright, set next target. Also, it's a good practice to wrap up the functions with the use callback, especially when you are using those in the use tick method. And let's add some variable here to track the target position. Okay, nice. All right, the same concept is applied to the target position. Yeah, let's actually change it to the eye position that we already created. All right, then what we need is the current direction, because we need to track the direction so that we can animate the sprites of the main character. Here we go, and let's check the target position. Okay, getting the X and Y from the current position, actually position current, and putting the direction to the current direction. Let's take a look what's not right. Yeah, I think it's about the nulls here, so let's just change the types. I think that should, yeah, that should fix this, but first let's put the new target, and we already have the function to calculate the new target based on the direction. Then, all right, let's fix that. Okay, let's fix that, and we're gonna use the new target. So let's check if we actually can move by using our function. If we can move, we change the target position. Now the same goes here, okay. Now, having this function set up, we set new target. Sorry, I misspelled that. Set next target. And we put the direction. All right. Now we need to handle our movement here. And we're moving only when we have target, so we check for the target position. Let's destructure here. Position, current target position, current. Okay, the move speed. And that's the time to introduce some new constant variable. So let's create the move speed in game world. Okay, so the move speed can be whatever. Let's just put something like that, some abstract value. Anyway, you will fine tune this. And eventually we put this delta that we talked about a while ago. So from here we get the completed flag and the position. But we already have the position, so let's rename it to the new position. All right. And let's change the position to the new position reactively. And let's check if it's completed. We need to basically set the target as null, marking the completion. All right. So now I'm moving this by using the arrow keys, WASD as well. Okay, it's being moved, but I'm moving the whole texture of the main character. And now when we have the controls in place, we can do something like that. We just display one frame at a time and then repeating this over and over again to create the animation. And we're using the use stick for that as well. So let's just go ahead and create a new file here. Use hero animation. Okay. Now we're just creating the function. As always, use hero animation. And we're gonna have props use here animation. So first, of course, is the texture. Then what we want to have is the frame width. It's because when we want to use some other texture, we can define that as well. We can adjust to any texture, total frames, and the animation speed. All right, so we basically can control anything here, more or less. So let's put the props down there. Actually, the type. Okay. Let's grab the each element will be grabbed from here. So texture, frame width, frame height, total frames, and animation speed. Now we're going to be using those. And the most important concept to understand is basically we're gonna change the sprites in a rectangular area many times. And usually it's like 60 frames per second, depending on the refresh rate of your monitor and your computer. However, that's all you need to understand. We're just changing the sprites, essentially making a slideshow. So we have frame ref and the elapsed time ref. Okay. So here's how we do this. We can create a function to create sprites, and we have another function to update sprites. And what we're returning here is the sprite and the update sprite. All right. So here, to create a sprite, what we're going to be doing, we're going to be traversing the whole texture with the rectangular frame, 64 by 64, and we're going to pick the texture based on the position of that rectangle. In a while it's going to be clear, I promise you. So here, as you can see, we're moving this rectangle based on a row and a column with a constant frame width and frame height. And we're using that frame to kind of snapshot and to create a sprite based on that snapshot. All right. Let's just also adjust the new sprite. All right, then the return new sprite, return the new sprite, and we can consider this function as more or less done. Okay, now it's time to use this, and update sprite will be receiving the direction, because for now our animation is dependent only on the direction, and then the flag whether it's moving or not. Alright, and here we need to have some kind of helper to help us to get the movement. Basically, yeah, the movement phrase. Basically, it's just we get row by direction, and that's it. We just need to map. And here, let's take a look and let's create the row by direction. And I think we have just 4 rows there. So based on the direction, we will change the row, and we're gonna loop in that row only. So let's use the switch. Okay. And I just looked at that before, and yeah, from the 9th row we just have those direction movements. So let's just define it here really quick. And yeah, maybe I should have typed a bit faster, but here's how I do this. Now let's just fix those typos. All right, we have the basic mapping kind of here. Let's just check. Yeah, it's the 9th row, as I already see. All right, so let's use this mapping here to create the animation. So we have the column and we have the flag, whether it's moving or not. And what we're going to be doing is we're gonna have the elapsed time ref constantly being added to the, basically it's constantly being added to keep the animation running, and we're checking if the elapsed time ref current is more or equal than 1, just because we don't have anything like half of the frame, we have only whole numbers there. So that's what we're doing. So this basically sets us up to loop the frames on one row. Now what we're doing is we're creating a new sprite based on those frames. All right. And we're setting the new sprite so that it will re-render, as you remember. Okay, we have the update sprite and we're good to go, I think. Yeah. Okay, let's just double check if everything's in place. We have a row here, okay. We have mapping. Okay, I think now it's time to use it. So let's just import our new hook. Okay, use here animation. Let's just put a texture there that we will also load. The frame height should be 64, frame width should be 64, and the total frames should be 9, as per the PNG file that we have. And a new constant variable, animation speed. This is abstract value, so yeah, try to adjust this as needed, but I'm going to create this animation speed thingy here. And let's put it as 0.2. Let's import it. All right. Now let's grab what is being returned from there, the sprite and the function to update sprite. Okay, so in the useTick, we have to inform this hook to basically tell, okay, there's the time to update the sprite, and we're going to be doing this with a flag, I think, which can be there as is moving. So this flag should be used to tell on this level, all right, we are moving. Yeah, and when you don't use this flag in your code, at first glance, nothing is going to be different than with this flag. However, under the hood, you're going to be doing a lot of re-renders. So let's just put it there. Because when it's completed, we don't want to re-render the whole component. So, and here let's inform our parent component so that the movement is complete, Let's grab the X and Y coordinates and let's give the parent component the information from here. All right. And the last thing I think here, we just need to update the sprite because we informed everything. So let's just update the sprite when everything's already calculated. We just pass the parameters. All right, and here, instead of using the static texture, let's grab this code, let's check whether sprite is there, and we put the texture from the sprite. Nice, finally we have something to show. So here, as you can see, we can control the main character. Okay. Also the collision map works. You remember the function that we created can move. Okay. So for now, let's just create the camera, the following camera movement, and we're done here. Okay, let's just create a camera component. Okay, fast. We create the camera component. We export the camera. Okay. What we have is the props as usual, and we need to know about the main character's position. Essentially, that's the only crucial thing we need to know. If we are the camera, yeah, also the canvas size. So let's put the props down there. All right. The camera will be a wrapper element, so we need to have the children as well. So let's define the types. Let's import this real quick. Okay. So the camera is basically a container, but we're going to be using something new here, which is called graphics. Let's just import graphics from PIXI because we need this graphics element to create a ref for the camera. So what I'm doing here is creating this new use tick. It's not the best example, to be honest. Remember to use as few use ticks as possible. But here we just put the ref to the container and we put a scale. But the scale in this situation is the zoom level of the camera. So we're creating one additional constant variable called zoom. Let's make it 3, whatever. And let's put children there. So now what we're doing here, we're gonna create some other variable to track the position of the camera. Let's just call it camera position. And we also have, I think we have the type already. The position type here. And initially, let's set it to the center. Okay. That's why I'm doing width divided by 2 and height divided by 2. It's okay. Now, in the use tick, we need to check if the container is there. If it is in place, what we want to do is we need to set the target. The target is where the camera will be going to. So we put it at the center. However, we take hero into account. That's why. We also take zoom into account. So As you can see, yeah, the same goes for height. Okay. Now, very interesting thingy is that we don't want the camera to be snapped at hero right after bat. What we need to do is make it go slowly. So that's what I'm preparing. So we have the container ref current is the camera position, okay? But here we need to change the position slowly. And here we have the lerp. Basically, it's just linear interpolation according to math. So we just return the start and minus start, and we have some multiplier that we're using. Now let's just put this function somewhere here as a helper. Okay. And let's import it. And this will help us to move our camera really slowly. Also, depending on this multiplier, you're free to experiment with that. And there we go. Let's just do the last steps. So we have here the camera, but as I mentioned, it is a wrapper. So let's put the elements inside the camera. And what's going to be within the camera component is going to be basically followed by the camera. Simple as that. All right, let's refresh. Okay, here we have this following camera effect. Okay, but what I already can see is that the offset of the hero is not perfect. So let's fix that as well. So we have our hero component and we have the anchor. Oh, we're left on this line. So let's just change it to 0.8 and let's check back. Okay, so looks much better. Now it looks more or less like game experience. We have the following camera set up. We have the controls working fine. And now I think it's time to add something to the scene. So let's add the coins. And by this, I will just show you how to add any elements to the scene. It's going to look basically the same as for the hero component. So let me just copy the code. Okay. To the coin component as well, let's just import. Basically, it's exactly the same like hero component, but the only thing which is different is the total frames, frame width, height, and of course the asset. But here, let's put the coin. Let's take a look how it's gonna look like. So let's put the texture real quick, and yeah, it's going to be looking just like the hero texture, but yeah, coin asset. Let's import this asset from here real quick. Okay. So here, what we have is the coin. We can put some other coordinates here to make more coins. So as you can see, the coin rotation is working just like our hero components animation. Okay, but usually in games we also have interface as well, and I'm going to show you how to put the interface. So here basically everything which is outside of the camera component is going to be treated like an interface because we're not following that. And as you can see, let's just put some coins there. And let's change the coordinates. I will show you exactly what I mean. Let me do this, and let's just change the coin texture because I also have a red coin. So this one would be a gold coin, and the same process for the red coins. Okay, coin red. Good. So we have the texture. All right. And we put a texture. So just take a look at this. There we go. So here we have pretty much everything. You have a backbone for your future project. You have interface, you have following camera, and you have animation setup. So please subscribe and hit the like button. Thank you.